like to bring up our first presenter, Andy's Technology co-founder, President and CTO Charlie Su, Director of Andy's Product Development and Technical Marketing. He has over a decade of Silicon Valley experience in technical and management positions. His technology contributions include the Sun of multi-core, multi-threading UltraSmart T1 and T2 processors, the C-Cube high-performance E-Series MPEG media processors, and the MIPS R10K processor, along with the Econograph Clipper VLIW processor. His topic presentation today is expanding the RISC-V horizon. The RISC-V architecture is growing, its membership is growing, and the RISC-V ecosystem is flourishing at an unprecedented rate. So Charlie will examine the expanding range of applications in RISC-V and what it serves, and how Andy's RISC-V solutions is help driving fast adoptions. Let's welcome our speaker, Charlie Su, President and CTO of Andy's Technology.
Thank you, Sean. Good morning, everyone. Welcome again to RISC-V-Con. So due to pandemic, we don't have it for the last 2 years, but we are back. So during the past 2 years, we continue to work hard to make RISC-V better. I think so do our partner. So today I'm going to tell you what Andy has been doing to expand the RISC-V horizon. So I'm going to first talk a little bit about the background. Then I would show the RISC-V, Andy's RISC-V core adoption from a packaging-specific perspective, and also from the different Andy's core series perspective, and then give a little bit unique advantage of RISC-V, Andy's RISC-V cores. Then I will talk about our new core on the horizon and some conclusion remarks. RISC-V and Andy's. The RISC-V Foundation was formed in 2015, and first year we have 13 members, and going to the last year we have over 2,500 people, members. And the ISA starts from the very simple IMACFD, Gold Berkeley, and every year we add big and small extension, and in the past year we have 15 new extensions. And I heard that total we have over 12,000 people in the working group to help to first extend the ISA. So RISC-V has many advantages. I think the biggest one is open and extensibility. So because open, so whoever can design a processor, you go ahead and do it to use it themselves, or like Andy's to design it to license to a customer. And extensibility allow custom to anyone who can add instruction to enhance it for the domain-specific requirement. And RISC-V vision is for all computing devices. So Andy's was founded in 2005, and we went public in 2017. And over the course of the past 17 years, we've been as a pure-play CPU IP vendor. We never changed the course. So we design our own instruction set architecture, and this start 3 generation, and over 10 cores, and also related software, including like GCC and Linux. We upstream to the public domain for that. And in 2014, we noticed something called RISC-V coming on the horizon. And we take a look, continue to analyze it. We found that it's very similar to our baseline architecture. It's complex, more extensible, and it added advantage of open. So after internal debate, we decided to base on RISC-V for our 5th generation architecture, V5. But we're adding our own extension to make it even better for our market. And we are quite active in RISC-V organization. So we are a founding and premier member. So we sit on the board and technical steering committee, and our members help to run some task groups. So Andy's RISC-V core adoption. I think easy to summarize from the edge to cloud, because RISC-V thanks to RISC-V is for all computing devices. So our customer chips have been in the mobile space surrounding the application processor, like in the touch, Wi-Fi, Bluetooth, and into the MCU, NPU, general purpose, IoT, and storage, and from consumer space to enterprise to data center. and also 5G networking, small cell, big cell, and also on the data center AI to accelerate the largest computation there. And since people can start to interesting to kind of application about the cloud, and recently we just realized that one of our customers, their chip gets selected in the satellite for the European Space Agency. So we are above the cloud into the space as well. And we are on the road too. I think this morning, we just have the announcement for Andy's first safety enhanced core, N25F-SE. So it is used by over a dozen, half a dozen customers in applications such as in cabin radar for the driver monitoring, auto touch and display driver, and also auto MCU, and auto storage using various places in the cars. So I also like to look at the adoption from our core series. So 25 series is a 5-stage pipeline. So Neuron using a D25F to run their industry-leading algorithm to keep the power consumption low. And SK Telecom using X25 to run Linux to serve as a controller to run their high-performance AI chips. And in 5G space, HQ using our A25 with custom instruction extension support, and Picocom using N25F, many of them in the cluster to reach maximum flexibility and also excellent performance. More on 25 series. Teralink using D25F in their IoT chips to run high-performance wearable devices, and also wireless audio and other IoT applications. And Phison use N25F to make their mobile storage thinner and faster. In 27 series, string computing using our vector processor, X27V, to boost their AI inference performance in their cloud application. So NX27V is very popular in this space, actually. So we have over a dozen customers using it for AI acceleration. We'll talk a little bit about it later. So our 45 series is dual issue 8-stage pipeline. It's used in Renesas RZ5 MPU, which is Linux capable. And the core use is 1 gigahertz X45 MP, which is RV64. And HP Micro, the HPN 6000 series, is a DSP capable and real-time MCU. They are different families using 1 or 2 800 megahertz D45, which is a 32-bit processor. Now let's look at a little bit about some unique technology we bring to RISC-V to our customer. First is for code size, which is quite important for quite some application in the kind of more code-sensitive chips. So if you use a IMAC FD floating point and B extension, which you already ratified as a baseline, which is most RISC-V chip use. That is a baseline, and right now there's a code size reduction task group in the RISC-V International. They define new 16-bit instruction called ZCE. You can further reduce the code size based on the benchmark down below by almost 5%. So the benchmark cover like code from the logic code from the like 60K all the way to 1 megabyte. So it's quite representative. So with Andy's RISC-V, because we're adding like a performance extension and also our patented code dense extension, here we don't include ZCE yet. You can reduce 70% code size over the baseline, or 12.3 over the ZCE. But as ZCE kind of go into the final stage of rectification, once it gets ratified, we're going to incorporate that to further bring the code size reduction benefit probably about 20% of the baseline to our customer. Now, low-speed compute acceleration, RVP draft extension is donated by Andis when we joined the early day. It used only integer register, so it's very suitable for compact and efficient endpoint processing. So here's some quick performance comparison with the ARM Cortex-M4 and M7 with similar instruction set or similar purpose. So if we look at RV32, our single issue D25F compared with M4, or dual issue D45 with M7. So no matter it's DSP library, we have over 50% speed benefit over ARMS. Or for the CFAR10 object detection, we have over 3x speed up over ARMS solution. Now, if you look at RV64, which has 64 registers, now you parry them double, so you get further speed up. But because ARM doesn't have 64-bit DSP, so we compare with RV32. So we have about 25% to 50% further speed up over RV32. So this is pretty efficient set of simple instruction. Right. And power efficiency is something which is usually difficult to do apple-to-apple comparison. But thanks to Renesas, they put our X45MP in the pin-compatible, feature-compatible chip, along with another chip they already did before using ACA55. So they have 4 different use cases. So for the CPU and DRAM usage, around 62%, and also the different usage, our X45MP can bring about 10% power reduction. But when the CPU usage can go into like 80%, we can bring down the power by half. So it's another benefit kind of coming from RISC-V compact instruction set. Now, high-speed compute acceleration. So this is a very generic scalable architecture. It's one control processor, global memory, and multiple cluster. And the control processor used to running OS, Linux, RTOS, and application, and also used to control the cluster. And cluster usually has a cluster memory and multiple processing element. And what is inside process element, or PE? Usually for this kind of high-speed computation, especially like AI or 5G application, it always comes with a hardware engine, which used to compute regular structural computation, which are less likely to change, so easy to accelerate by direct hardware. But it also needs a compute processor to process the more dynamic paradigm, and you may continue to change based on environment or your algorithm. So a RISC-V vector processor is very useful here. And it needs a powerful compute unit, and also need to have a high bandwidth memory subsystem so that it can facilitate the efficient communication with other processing elements. And also to work with the hardware engine efficiently, usually you need extensible ISA and interfaces. For this, we call it streaming pole, because you can stream the data computed by hardware engine and directly into vector register, and then do further post-processing, or do pre-processing and then move the data to hardware engine. So we are very happy that the streaming pole that we talked about almost 2 years ago, actually over 2 years ago, now picked up by another RISC-V company. They finally find this is also useful. We're happy to share that. So and in our custom application, that X45MP 1 core to 8 core is very useful and being used as a control processor. And X27V or used as a compute processor, I think over a dozen custom projects. We support the RISC-V vector extension up to 512 bits VLAN, and also SIMD, which is a computation unit. And this custom extension to facilitate the hardware engine, which is an automatic tool to to help customers to add instruction and create interfaces. I think later part today's program, our colleague will talk about ACE a little bit more. And on the right side is a kind of configuration to show that when you have 128, 512 to 512, and it measures the speed up by a wide variety of application, and so normalize it. And if you normalize speed up, and also compare with the area that because you had longer vector and so on. So we find that in our NX27V, the speed up go much faster than area. So this is very area efficient architecture. Okay. So another good thing about this architecture is it separates the decision of control and compute processor. You don't need to tie them together. Not every code needs to run Linux. You can have a code running application and another code focus on compute acceleration. Probably never need to deal with much interrupt. Okay, now let's look into the NDIS roadmap. So this is what our current lineup. So we have entry series, 25 series, 27 series. Those are 5-stage pipeline. The 27 with better memory subsystem for those who need it. And then 245 series, which is 8-stage dual issue core. And together, those series have cover different applications from embedded control and compute acceleration based on a DSP or vector instruction set extension, and also running Linux application, a single core, multi-core. And here I want to point out NX27V and D25F is the world's first RISC-V vector and also DSP capable processor. We push out on the market first, and these two cores are quite popular in our customers. And with the newly announced safety enhanced core N25F-SE, we can introduce the full SAF feature to our lineup now. So in our announcement today, we categorize N25F-SE as the world's first RISC-V core with ISO 262 full compliance. So what does that mean? For full compliance, it means it is certified for all required parts of ISO 262 standards, which including parts 2, 4, 5, 8, and 9. And you probably heard a lot of core claim they are 26262 ready. So what does it mean? Ready means it's not certified for all required parts. So usually you certify by 1 or 2 parts. So ready is not really ready. So we, those who are old enough probably remember cable-ready TV, which means you need to have a box in order to watch the cable program. So with 26262 ready cores, SoC team must do the work that CPU IP vendor are supposed to do. But if you use N25F-SE, you save a lot of time, you save a lot of effort to go through those paperwork, also the verification that you need to do to calculate the coverage and things like that. So now also let's look into the NDIS core on the horizon. So we'll introduce X60 series, which is a 13-stage auto-order multi-core, and with X65 as the first member of the series. It will be over 2.5 gigahertz at 7 nanometer, and had 2x performance over current high-end, which is X45 MP. So 2 weeks from now in the Lindy Process Conference, I will disclose more detail for this X60 series and X45 specifically. And we also adding new member to the 45 series, which is a 45 MPV. So from the name, you know it's multi-core and it's a vector. So we will extend the VLAN from 512, which NX27V has, to over 1024. And the preliminary performance data show that it would have over 20% to 40% higher performance over NX27V with the same VPU configuration. In the entry series, we introduced a D23, which will have a code mark over 4.0, and it has smaller code size. And we bring in DSP SIMD extension and 14-point extension, and also security enhancement. So we'll talk about X45 MPV and D23 in the RISC-V Summit at the end of the year. Now, with N25F-SE, we started with the functional safety feature. It's not alone. So we plan to have one ISO 26262 compliance call to deliver every year. So at different series, so to address different performance requirements and also different usage. Right, so we all know that RISC-V is the leading choice now for processor of SoC and computing platform, and often is the best choice because with extensibility and open, it's not something that other code can compare. And this makes RISC-V even better by extending its ISA and interfaces through our anti-custom extension framework and tool. A lot of our customers been adapting it. And also by extending the ecosystem by working closely with our partner. And with that, and just bring the RISC-V benefit to application from the edge to the cloud and beyond. So I want to say that with our 17 years experience, over 300 customers, and 80,000 ID users, and over 10 billion custom SoC shipment, and this has the best track record in helping customers succeed. And with that, I conclude my talk. Thank you.